Hello everybody, this is Digital Blackboard by Sachin P. Nagmote. In this video, we are going to discuss the topic Linear Variable Differential Transformer, that is LVDT. So before starting discussion on LVDT, let us define transducer. So transducer is a device which converts one form of energy into another form, or which converts physical quantity into electrical signal. So our LVDT is also a transducer which converts linear motion into electrical signal, or which converts a mechanical displacement proportionally into electrical signal. So in one line, LVDT is used for linear displacement measurement, and LVDT's function is similar to that of transformer. So let us revise the function of normal transformer. So in normal transformer, we know that there is one primary winding, one secondary winding, and iron core. And when we provide the supply voltage, AC supply voltage to the primary winding, AC current flows in the primary winding, and this AC current produces a flux, and then this flux links with the secondary winding, and according to Faraday's law of electromagnetic induction, there is mutually induced EMF in the secondary winding. Now this mutually induced EMF in the secondary winding is directly proportional to the rate of change of flux with respect to time. So one thing is very important, whatever flux is linking with the secondary winding, that flux is responsible for the induction of voltage in the secondary winding, and whatever voltage induced in the secondary winding is depends on the flux which is linking with the secondary winding. So in LVDT, we are having one primary winding, one iron core, and instead of one primary winding there are two secondary windings. So it's clear that in secondary winding there will be two induced EMF, E1 and E2, as there are two secondary windings. But these two secondary windings are connected anti-phase with each other. So as these two windings are connected anti-phase with each other, so the total secondary voltage, that is E0, will be the difference of these two EMFs, E1 and E2. So E0 is equal to E1 minus E2 or E2 minus E1. So now we will just displace this iron core. So if we displace this iron core, what will happen? Let's take a look. So as far as the construction is concerned, there is one primary winding, two secondary windings, movable iron core. Two secondary windings are connected antiphase, and hence the total secondary voltage is difference of E1 and E2. Now if we keep that iron core as it is, okay, so as in this case we are assuming that the same flux is linking with two secondary windings S1 and S2. So if the same flux is linking with S1 and S2, so but natural, the EMF induced in S1 and EMF induced in S2 will be same. So E1 is equal to E2. So if E1 is equal to E2, then the total secondary voltage will be 0, because these two secondary windings S1 and S2 are connected anti-phase with each other. So the output voltage of secondary is equal to 0, and this is called as null position. So null position is a position in which EMF induced in both the secondary windings are equal, and hence the secondary voltage is 0. So this is the first case in which we are having 0 voltage at the secondary. Now if we displace the iron core in forward direction, now see what will happen. If we displace the iron core in forward direction, it may happen that the flux linking with S1 is more and the flux linking with S2 is less. So if the flux linking with S1 is more than S2, then what will happen? E1 will be greater than E2. So the EMF inducing S1 is more than EMF inducing S2, and that's why E1 is greater than E2. And as these two windings are connected anti-phase with each other, so if we connect one AC to DC rectifier in between that, so we will find that as E1 is greater than E2, E0, that is the difference of E1 and E2, is positive. So if the value of E0 is positive, it means we are having the displacement in forward direction. This is the second case. Now in the third case, if we displace that iron core in the backward direction, it may happen that more flux is linking with S2 and less flux is linking with S1. As a result of this, what will happen? The EMF induced in S2 will be more than EMF induced in S1. That's why E2 is now greater than E1. Now as these two windings are connected antiphase with each other, so total EMF at secondary E0 will be now negative. So this negative voltage at secondary indicates that the displacement is in backward direction. So from these three cases, it is clear that the displacement of this core result in the change in the value of E1 and E2, and change in the value of E1 and E2, change in the value of E1 and E2 results in the total secondary voltage E0, and that's why the change in the total secondary voltage E0 is our electrical signal. It's the electrical signal which is equivalent to the displacement of core. Hence, this arrangement, that is LVDT, is used for the displacement of, for the measurement of displacement. Okay, so as far as the applications are concerned, LVDT is used for the measurement of displacement from millimeter to few centimeter, and as a primary transducer it converts the mechanical displacement into electrical signal. So here we are having construction, working and application of LVDT. So I hope you understood the topic LVDT very well. So please like, share and subscribe Digital Blackboard. Thank you very much.